Hello. In this video, I would like to generalize the Freddy-Gauss formula for arithmetic sequences. This video assumes that you know how little young Carl Friedrich Gauss added up the numbers 1 through 100. If you haven't seen that story or heard it, look it up on the internet. So, to sum up the first n natural numbers, 1 plus 2 plus 3 all the way up through n, and that can be written using this summation notation, I going from 1 to n of I, is n times n plus 1 over 2. I would like to generalize this. And we're going to be looking at what's called an arithmetic sequence. This is a sequence that has a common difference. So here's our first example. 21 plus 23 plus 25 plus 27 plus 29 plus 31 plus 33. This is a list of numbers. We are adding them together, and we do have a common difference between successive terms, and that difference happens to be 2 in this case. As Friedrich Gauss did, he made a second copy of the sum, but the numbers listed in reverse order. Then he added up the columns, and you'll notice that in each column we get a constant of 54. So 2s is going to be 54 times the number of numbers, and it looks like we have 7 numbers. So s is going to be the first plus the last. 21 plus 33 gives us a 54 times 7. And then we divide by 2 so that we just get s instead of 2 copies of s. This sum is 189. So now we are ready to generalize. To find the sum of an arithmetic sequence, we can take first number plus last number times number of numbers divided by 2. Let's see a worked example of this. Let's say we're given this summation. Summation I goes from 1 to 6 of 3i minus 7. Now maybe for parentheses or for emphasis we should put parentheses around the 3i minus 7. This is implied, but we'll put it in for emphasis. Now what this means is the index I is going to take on the integer values 1, 2, 3, 4, 5, 6. So we're going to get 6 terms. When we plug in I equals 1, we have 3 times 1, which is 3, minus 7, which is negative 4. When we put in I equals 2, we have 3 times 2, which is 6, minus 7 is negative 1. I equals 3 will be 9 minus 7, which is 2. Then I equals 4, then I equals 5, and I have intentionally not written those terms. And finally, the largest I value is 6. When I plug in 6, I get 18 minus 7, which is 11. The reason I did not write out these terms is I don't need the middle terms to use my formula. This is a great formula. First plus last times number of numbers divided by 2. Negative 4 plus 11 in parentheses times 6 divided by 2. This sum is 21. Pause the video at any time as you wish. Now I'd like to do another worked example. The directions here are to write the following using sigma notation and find the sum using the formula. So our sum here is 50 plus 58 plus 66 plus 74 plus 82, and we do see that this has a common difference. This time the common difference is 8. So I'm writing the sum this way. Now this does require a little bit of work. You might want to pause the video to see if this makes sense. There are 5 terms here, so I is going to go from 1 to 5. The number that's multiplied times I is the slope. This is like a linear function, which is the change from one term to the next. Also, in order to force the first term to be 50, I have 8i plus 42, so that when I plug in 1, in fact, I do get 50. When I plug in 5, I have 8 times 5, which is 40, plus 42 is 82. It does check. So I've followed the first set of directions. Now we just need to plug into our formula. First plus last times number of numbers divided by 2 is 330. Have a great day.